Hey guys, we're going to be looking at some examples on how to simplify radicals. So you should remember most of this from Algebra 1, but we are going to go over some examples. It's important that you know the first 1 through 20 of your perfect roots. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and so forth all the way down to 20 times 20, which is 400. So these are going to be super important to know for this unit. Okay, so let's go over here. So let's start with an easy one. We have the square root of 49. So square root of 49, 7 times 7 is 49. So this one is going to be 7. One thing you have to remember when you simplify radicals is that you always are going to have a positive and a negative version. And why that is because positive 7 times positive 7 will give you positive 49. But also negative 7 times negative 7 will also give you positive 49. Okay, let's look at the second example. So I'm just going to keep the 2 on the front. We can't get rid of that, but we can look at the square root of 144. So if we look over here, we know that 12 times 12 will give us 144. So we're going to just put 12. The only thing different with this one is since that 2's in the front, we're now going to have to multiply it by the 12. So if there's ever something in front, you just multiply it by whatever you take out of the radical. Okay, and keep in mind this little sign is what the radical is. So 2 times 12 gives you 24. And once again, because it was a square root, it's going to be a positive or a negative 24. So answer. Okay, so example number 3, it looks a little tricky. It's not really. Anytime you have a fraction under a radical, you have to change it to the square root of 4 over the square root of 9. That's just the easiest way to break it down. Then we can look at it and say, okay, well, the square root of 4 is 2, and the square root of 9 is 3. And then, of course, because it's under a radical, we got to put a plus and a minus sign. Okay, so let's look at some more tricky examples. Okay, so if we look at our chart, nothing times itself is going to give us 245. So what we're going to have to do is we're going to have to break it down and figure out what times itself will give you 245. So what one of these perfect roots times any number will give you 245. So I'm just going to come over here, and this is what you should do too, because I don't know this off the top of my head, so I don't expect you to either. Just come over here and start dividing 245 by these perfect roots until you get one that sticks. Okay, 245 divided by 36. No, 245 divided by 49. There we go. So we have 45 times 5. Okay, so all I did is we took the square root of 245 and we simplified it, and we rewrote it as 49 times 5 because that equals 245. Now, because 49 is, a perfect root, we can take it out. We know that 7 times 7 will give you 49. So we're going to put a 7 on the outside, and then we're going to have to keep the square root of 5 just because square root of 5 is not a perfect root, so we can't take it out any further. Okay, so this will be your final answer, but of course this will also give you the positive and the negative version. Let's look at one more example like this one. So I'm going to keep the 9 on the outside. We know we're breaking 45 down into a perfect root times something because 45 is not a perfect root. Okay, so 45 divided by 4, no, 45 divided by 9, boom. Okay, so we can rewrite 45 as 9 times 5, and some of you'll be able to instantly say, oh, okay, well, I know 9 goes into that. If not, like I said, just take your number and divide it by every single one of these. There's nothing wrong with doing that. Okay, so now we're going to keep the 9 on the outside. When we pull out the square root of 9, we know it's 3, so I'm going to have to say times 3, and we're still going to have the square root of 5. So the only thing that changes here is you have to know when something's on the front. So we started with the 9 up front, and then we pulled out a 3. We can't just put them together because that would give us 93. We actually have to multiply them. So we know that 9 times 3 will give you 27, and it's still with the square root of 5 on the back, just because, once again, 5 is not a perfect root, so we can't simplify it any further. And very last step, we have to make it a positive and a negative version.